Hey everyone, welcome to Coorlas Architecture. I'm Stephen Coorlas, owner and architect, and today we're going to take a quick look at a unique remodel project converting an attic space into a bedroom, modeling it in Revit. So let's jump right in. Okay, so before we start, I'll just show you the existing conditions survey here, and if you're familiar with our process, you know that we use Magic Plan, which is a great app to document the existing conditions. Here I've got the bedroom area selected, or what will be the bedroom. It's an attic now, and some of the photos that are associated with that space. If we take a look from the exterior, you can see it's a pretty standard hipped gable style roof. So we know we're going to have to pop some lights in here, meaning windows, for egress and per code. So let's jump into our Revit model and start modeling this up. If you're familiar with bringing in exported DWG or DXF files, that's what we'll do first. So I'm going to go to my Insert tab and Import CAD. Magic Plan allows you to export the plan as a DXF file, so I'll navigate to it here. Drawings, existing. Make sure that you select the proper file type, DXF files, and there we go, we got the second floor. And I always like to just keep it black and white, and all the layers are showing, so none of that should really make a difference. Current view only, sure. Correct lines that are slightly off axis. That does help with buildings like this that are mostly orthogonal, so it's fine to select that. Usually just drops it in, sometimes a little off the view there. So, and it's pinned, so if you have, do not select pin objects selected, you'll have to remember to change that in your modify tab there over to the left. So I'm going to select it, unpin, drag it over to the center, and I have this model or template file in Revit pretty much started already for all new projects that have the grid lines already in there. So it's easy for me to just navigate to a level 2 and drop this in there, and we're ready to model. Okay, so like I said, it's a little bit off of my view here, so I'm just gonna pull the viewport down so we can see everything there. Now for this scope of work with this client, I was only commissioned to do this room, so I'm not going to bother modeling up the rest of this right now, but we'll focus on a deliverable, which basically takes this space and converts it into a bedroom as a concept design package. So the first thing I like to do is align my grids. So I'm just going to take this and drag it over. The reason I don't use the align tool, which is right here, for that process is sometimes, even though you select the straighten off-axis lines when you're importing, the lines can still be non-orthogonal. And if you do that and you start with aligning a grid to a non-orthogonal wall, the rest of your model is going to be messed up from that point forward. So definitely better to just move and kind of align it with the move tool rather than actually using the align tool. So same thing over here. It doesn't look like we're going to need this D, so I'm just going to erase it. I've got A, and then we'll do C, and then we'll center the B for the center point of the roof. So for this one, let's move this over. And then, like I said, we'll just take this, tab it over a few. These are annotate, align, grab my grids, and equalize it. Okay. So then I can probably tighten this up a little bit just to focus my scope of work for myself. And that's it to start everything. I mentioned that this was out of the scope, but I do know that this actually turns the corner there. We'll take a look back at this. This view back here was looking basically from that side of that wall, looking back down into the space. So right along here. I didn't survey it because I knew that I'd just be able to connect basically that line to that line, and it'll be easier to model than it would have been to survey. So I actually just remembered that I do have existing drawings for this remodel, which is always very helpful, and I like to bring them in. So what I did here is you can just drag and drop an image. If you select the image, you can come here and say send to back, and it'll put it behind all of your model lines. So it's a little difficult to read and understand, but I'm basically just lining up the grid lines, one down here with the bottom of the drawing. His previous drawing was inverted, and so I've aligned it with my grid line 1 and grid line 4 at the top and bottom. So that's going to help me locate this grid line 2, which looks like it's approximately, let's see, 21 feet, 2 inches. Sure. I mean, we'll keep it like that in our model, and just for anyone's reference, remodel projects, obviously there's a tolerance for some of the things that you can and can't see. I'm just going to hide this behind walls. So if you are putting a scope of work together for contract purposes, just remember to include, there's going to be unforeseen conditions with remodels all the time, always. No two buildings are alike, especially in terms of residential. So just to protect yourself, that's always a good idea. So now that we've got our grid lines associated with the architecture of the building, we're going to go ahead and start modeling in some walls. And I'm going to do the lower walls as well as the roof, and then we'll add in some of our perimeter walls there. So we can take this and copy it down to the first level, paste in place, and I'll use that for my wall placement at the ground level, which will then serve as the supports for our floors up above. So I'll just take some walls, reviewing again the home exterior. It is a brick home, so we'll use a stud wall with a brick finish layer. I've got these wall types made so it's easy to just kind of come in and grab something that's similar. Brick on stud, 4-inch brick, 1-inch air gap, 5/8 inch ply, 3.5-inch stud, and then a 5/8 inch interior. So that ply might change from job to job. I think that might have been holdover from a job that had a specific plywood size in it. But again, make sure that when you're modeling this, you're using the grid lines and not necessarily the surveyed lines. Sometimes it might not make as much of a difference more than other times, like this in this case, but it's just something to be aware of. So I just want to get the perimeter of the building here, and let's make sure that our exterior was in fact pointing outward, and yes. So something else I just remembered to keep in mind is the survey dimensions. If you're doing interior survey, you have to remember those are interior to interior wall dimensions. So the grid lines that you place down may be aligning with the assumed exterior walls that your programs are assigning or you have assigned in your surveying program. So in this case, I do have a certain dimension that I surveyed, which was 22 feet from the inside to inside at the base of the roof line in the attic space. So I want to just come in and make sure that that dimension is actually set to 22 feet. So, and after I do that, I can just make adjustments, basically shift this to align with that new stud wall. So again, I'm going to take the actual drawing and move it over. That's underneath. And I can see if, yes, my drawing underneath is in fact lined up with the 22. We'll remember to just recenter this by editing the witness line, grabbing that. Okay, so it's already locked in there. It's constrained, so that's good. Then I'm going to come back in and do this again. I'm going to take the grid lines and align the inside face of my walls with those grid lines. So same thing for this outside wall, and same thing for this wall over here. There's a lot of lines, so make sure you're grabbing the right one. And then I'm just going to slide this down since we haven't really started modeling too much yet. These are just kind of the precursor phases to getting everything set up properly. So the inside of this closet wall was the back wall of this attic space. So again, I'm going to take this and slide it inward. So now I know all my inside dimensions are set properly for and based on my survey. So now that we got these walls, I always like to toggle between my 3D views just to make sure everything's kind of developing properly. And there's usually some steps that I forget to plug in when placing the walls, such as constraining the top height. So for this, we will do up to level 2. So I know these walls are coming up to level 2, and then the floor joists will span with this top as the top surface of the floor surface. So jumping back in. So when you come back to your level 2, if you've reset those, now those are going to be below your visibility plane in some cases, but the level 1 still shows it down here. And this is now off. So we'll just erase that. Like I said at the beginning, I have sort of pre-set up templates. So elevation views, all these sorts of things are pre-set up and placed on sheets just to help move things along quicker when developing concept designs, things of that nature. So we adjusted our grid spacing, but the 2D placement of the grids still needs like refinement when these are on sheets. And like I mentioned, these are already on sheets. So just as an example, if I come to my level 1 floor plan on my sheet, I've got my general notes, but the elevation tags are flying around, and those things need to be kind of adjusted accordingly. And now I don't think we're going to have any exterior views on this, but if you did, obviously those have to be adjusted, and then exactly where this goes on the sheet would make a difference also. So a little bit of cleanup to do, but overall it's nice to have these things just kind of pre-set up in a template. So now let's get into modeling the roof here. Okay, so before we actually jump into the roof, I just want to come back to the base level, and I think it'd be easier just to have a full first floor plan so that I know where the new floor is going up above. So I'm going to take a couple more of these walls, and like I had mentioned, since these are not in scope over here, the accuracy of them isn't going to make as much of a difference. So I just want to get these sort of in place and everything modeled up so we can put our floor plate in first. All right, that's looking pretty good. Now, if I model in a floor plate, go to Architecture, Floor, and I've got some models that basically just have the joists in place. And I do know that the majority of the joists, at least based on my survey, are under 12 inches, so they're undersized. If I come back to here and I measured the actual joist, that was in the garage, measuring that beam that was going across, and these were sort of suspended joists, which is a unique condition, but these look like they're 7 1/4, so 2x8s. Definitely not sufficient for our floor framing, but we want them to be for the new area, so we're going to be replacing those at least up to the grid line 2, which is the garage area. And then everything beyond that, we'll have to do some discovering as we do selective demolition, but I'm going to model them in as 2x12 joists in this area. So we'll use the floor. We'll grab our 2x12s with 3/4 inch sheathing, and I'm going to model it on level 2 with a minus 0.75 inches from my level 2 to compensate for hardwood flooring, which is typically 3/4 of an inch if it's real hardwood. And then just take my shape tool, and we'll come in here, come to the inside face of the sheathing, since they'll be supported on the studs below, and do the same thing here. We might have to use our align tool And there we go. So that'll get us started. Again, toggling in 3D just to always kind of confirm where you're at. And there's, obviously going to be some overlap with where you place that, but in your sections when you cut, it makes a little more sense that the floor or the joists are actually overlapping that and resting on the stud. So that's how I like to do it. Now that we got our floor in that area, we'll do the same thing for this area, and maybe up above we can see exactly where that would go. And I'm assuming, since it's an older building and we have some smaller spans, that the stud or joist depth is 2x10. So I'm going to take a look at 2x10. And for this one, we got a detailed view on. For this one, we'll align it with where we were. And we'll sort of track along these wall faces. So there's a hallway area, and this drops below. So if we're mapping this down below, you can see this hallway opened up to upstairs. This obviously is not going to look like that. There was a notch in that area upstairs right here, so these should come all the way across. So I'm going to delete these. Just start trimming this up. And like I said before, we don't need to model in all of this, but there's a catwalk up above, which looks like it should be lining up around here. And again, the reason why we like to do the surveys is because, as you can even see, one was hand done. It looks like a long time ago. And we always find that dimensions of as-built are different from plans, even like permitted plans, and what's built and on site. So it's important to always do your own surveys and go off your own dimensions. So, but for the remainder of the space, like I said, I didn't survey the downstairs, so that's good enough. I'm going to focus on this area here. So it looks like that should be okay. I know this actually steps in here and comes across to this wall here. I believe it's open. So this does step back like that. And then this is going to connect there. Okay, a little bit of a puzzle there, but I think we've got our 2x10 second floor. So it's got the same parameters, setting it on the level 2, 3/4 of an inch drop down, and there we go. Save, yes. So if we take a look now, that's more or less what we have. We'll start to go through here and turn these on the proper layers for our demolition drawings. It's not new construction, this is existing, but this would be a new construction, so we'll leave that, and then we would have to, if we wanted it to appear in our demolition drawings, copy that and put it on a demolition phase. So I'll do that now just so I remember. Copy, paste, align to same place. And this I know was the 2x8s, so you can either go through and make a new floor type. Since it's being demolished, it doesn't really matter. I'll probably just use a keynote or something to call it out as a 2x8 that needs to be demolished. And we'll set that as existing. I know it's already selected there, so it's assigning these parameters to it. And existing, phase demolish new construction. So if you do have a demolition plan, this is all scattered. It would show it in here as being demolished. So here we go. We've got our floors, and now we'll model up just the roof plane that's coming in over that, so we can start to get a little bit of an understanding of our space, our head heights, and what's going to be kind of permitted and allowed up in that area. Okay, so it's a pretty steep roof. I have dimensioned in the model that it's 16 feet. So in my details, if I select on it, I took a laser measure and put it on the joist, hit the rafter beam, and saw that it was 16 feet. So we're going to start with that and then kind of figure out what the pitch of the roof was. So it helps to come into some of your other views at this point, like your elevations. So it looks like my elevation is kind of cutting through the building, but the point of this was to basically come in at my level 2, go up 16 feet, and that's going to be the top of the roof, which looks pretty steep, and that should be pretty accurate. Use my align tool, get my top of roof up to that level. So that way I just have a gauge, and we're going to do our roof. We'll go to our level 2 floor plan. We can model in pretty much the whole roof. We just take another look at the shape. I'll see if we can get it in one shot there, not modeling in the dormers right now, but just the primary roof. So it might actually even help to go down below to our first floor plan, because it's got all the perimeter walls. So it was a good thing we modeled the entire perimeter. I'm going to hide this. It's got my perimeter walls. I'm going to hide this, or at least override the graphic by element, put it on halftone. Okay. We'll just expand this for now, since I don't think I'm going to be using the first floor plan. And architecture, roof by footprint, yes. Roof type, 2x10, asphalt shingle. Use my select by line tool, and just looking at this one more time to see how much of an overhang there was and everything like that. We've got a pretty decent overhang. That's, probably a 2-foot overhang. So we'll model it like that. First we'll just grab the perimeters, and let's see how well the Revit interpolates the roof geometry here. It's steep, so we can start with a 9x12, and let's just give that a shot. We'll reset this to 0 offset from the base level. I'll click OK. Make sure everything's connected. Come in 3D, and it's not on the right level, put it on level 2 or bottom of roof. I have a separate level for bottom of roof so that you can kind of control. So in this case, obviously it's at the wrong level there, but I'll take this and move it down, probably to align with that, but sometimes it dips below. So just make sure you're looking at that correctly. So I'll have to take a section slice through here and measure 16 feet up to see how close we are with the roof line. Just taking a second look at it, it definitely looks like it's it could even be over a 12 by 12 pitch roof. So let's just start with the 12 by 12, and that looks a little closer, and looks like Revit did it right with the hip kind of extending up there a little bit, and we just have to offset this 2 feet around the entire perimeter 2 feet, make sure it's not copied, grab it, tab, so it selects all the lines, shift it out, and there you go. Got our kind of mushroom top there. So let's go into our floor plan, drop a view section slice through here. Go to view, right click, go to view. And that was my 16 feet from the level 2. Just to confirm, I'll remeasure it. Yeah, so wow, I mean, I think we're looking at over a 12 by 12, and the next one up would be a 14 standard, and there you go, it's exactly there. So a 1412 roof, very tall, but that's what it is. And this is a good opportunity to kind of see what we have in terms of head height clearances. So just a reminder, when you're doing plans like this for municipalities, and if they have FAR restrictions, floor area ratios, typically you want to look into what they have as allowances for head height, meaning square footage areas that don't count against you if they're under a certain head height. So I like to take my just drafting line here. 6'8", 80 inches is typically your line that will strike for the head height allowance. And I believe I do have a component in here. Detail. Let's see. A little 2D person silhouette. Yeah. So this guy should be about 6 feet, which is 5'11". A little above average, but it just kind of gets you an understanding of where the head height clearance is. And for this instance, it's pretty good in terms of usable space all the way out to the perimeter. It looks like we're only losing, if I drop my line down here and measure it to the perimeter wall, less than 3 feet. So you can do some low closet storage, which would be nice along the perimeter, and that is what we talked about. But you don't have to set the wall there. Obviously, there's more usable space here, and if our joists are flying out and capturing the edge of the roof there, so that's again, for instance, why we like to set the bottom of roof a little lower. You get a little more usable space basically down into that corner there. So this is looking pretty good. We've got our model pretty much modeled up. The next step is going to be to start placing some walls and getting some windows in here that can be used for egress. Okay, after a brief little aside here, I did a little more research on some of the information I had on the survey. And it looks like it's actually a 13/12 roof pitch. And when I aligned this with a Google Street View image, it made a lot more sense coming from grade to the bottom of roof with a 13/12 pitch. And I realized the 16-foot floor to ridge beam dimension that I had was for the upper roof. So I've gone ahead and lowered this to the more accurate dimension for our lower roof, and now we're coming up with something more like this. So I took my roof plane with some of my more research, found that it was actually a 2x8 rafter for the roof framing. So I went ahead and changed that, and then if you can see here, this detail for the roofing is called a bird's mouth cut on the rafter that sits on the floor joist or wall, exterior wall. So here's a photo of what that looks like on the inside here. It's when they notch the rafter so that it can sit and have some bearing on the top plate, and they call it a bird's mouth cut, and because it sort of looks like one. So anyway, I made those adjustments, and now our what we'll call permitted square footage or head clearance space volume is much smaller than what I anticipated before, but that's why it's good to just kind of do some of this research and get the building really the way it is. And so now we can see actually that what we have from the head height clearance to the perimeter is more like 6 feet. But I know I want to put a 3-foot closet door wall in, so I'm just going to draw sort of a temporary line in here and see where that gets us. And we can adjust that height to maybe 4 feet if it makes more sense for some of the standard door heights and things like that. Let's just do that. It seems like it's going to be a little more accessible. Just offset this 1 foot up. Bring this back out to align with the exterior wall. And that's going to be my 4 feet. You'll have to compensate for 5/8 inch jip at the ceiling that transitions to the wall to have that exactly accurate, but this is close enough. So what we can do to just start modeling those in is go to our second floor plan, and this is where you'll have a lot of overlapping lines and things like that. It can be difficult to see through. You can also adjust your cut plane or just hide the roof in the meantime. So I'm actually just going to hide this for now while I model some of these in. And what I was doing before was doing a wireframe view so I can see my surveyed plan down below, because once you start modeling things in, that goes to the background. You can also bring it to the front, and let's see if that helps. No, it doesn't help in this instance, but doing the wireframe does. So if I just take a standard wall, and I can't imagine we would drywall the inside of these walls, so I'm going to do something more like a standard 2x4 interior stud wall with 5/8 inch jip only on the exterior face. So I've got a stud wall type for that right here, 5/8 inch jip. Click on it. It's always hard to tell which face is on the inside or outside, so I want the interior finish face interior, and I'm just going to drop it down, and we can adjust it in our section. So it was the wrong way. I can use this little arrow key to flip it, and once we get into our section we can just mirror it over. So that was actually pretty close. And then again, like I said, if you want it to be exactly 4 feet at that nexus point, you'll have to also compensate for the jip that will be coming down from the ceiling, which in this case, if we get a perpendicular line, 5/8 of an inch, and then draw that perpendicular line, that would actually be right here. So I think we can just take this, move on that point all the way over to our 5/8 inch jip dropping down. And to make things, to clean up the geometry, you can always grab the wall, attach top, select your roof rafters, and it'll clean it up perfectly nicely. And you can see at that nexus point, that should be exactly, if we measure from the current level, level 2, 4 feet right there. So now I can take that and mirror it over. We'll just use our mirror, make sure it's copying, yes. And this will make the volume of the space appear a little more volumetric and spacious, but obviously per code, if you were doing the FAR, just a reminder, you'd only be able to, or you'd be allowed to only use this space. So what I do in those cases to measure is basically like you're seeing here. You can take the 6-foot 1/4 inch off from the column line C and basically use that dimension to draw in your floor plan those lines, and then take your square footage in a plan view. But for our instances, this is good enough for now. I think at the perimeter wall, we'll have to do the same thing for this offset, so we should cut a section going the other direction. So view, section, drop this down, just take it all the way for fun. Go to the view, and you can see this is the wall that we just put down, so it should basically align with this exact point right there, our new wall. So I'm going to go back into my floor plan view, copy this, rotate it, just shift it down a few notches. So another way you could do it is probably just use that line. Let's just test it out and see if that works. My section 2, I haven't named these yet, and there you go. So it's perfectly aligned there. Take this wall, attach to the roof. Okay. So we'll go back in our floor plan, clean up the edges of the walls, since we know those perimeter spaces are going to be basically captured like that. And we'll have to consider at some point the egress window, cutting it into the roof as either a skylight. We'll need to double check and see if that's permissible, or to create a dormer. So obviously these walls at some point would cut out into a dormer space to make an accessible floor space to get you out to a window there. So what I haven't done yet is model this back wall, which is the closet wall, and this sort of unique geometry that turned that corner there. Like I said, I had some photos that looked at that. That's this view here. If you kept going around the corner, you had a little more usable space. Definitely not a lot of head height clearance, but it is back around that side. So I think I'm just going to start by recommending to close that off with an access panel. And we'll see what the client wants to do in terms of making that like a little seating lounge space, occupiable space, or just some closet space. So since I have this wall already mocked up here, I'm just going to grab it, copy, paste, rotate. And this should be a two-sided wall since it's facing both directions. And just snap it to my wall over there. And I can bring that to the exterior. Let's see if this is snapping to the roof. Attached to... It is doing something funky here. I've noticed issues with walls snapping to the underside roof across like a gable roof. So it's not, but I wonder if I just grabbed the wrong side of the roof or something. No, so it's being goofy, and it might just be because this line out here is too far out. Yeah. So we need to basically find, let's see if we can select the edge here, right click, disallow join, and align it with the inside face of this wall down below. That should get us pretty close to the edge there. Then we can come back in our floor plan and use our trim extend tool to get that face to that face. And then this corner also had some unique bump outs here. So if we go back into our 3D view, we should be able to see kind of some of the constraints that were happening at that corner. And I thought it was because of some framing that was happening. So, what's missing in some of these roof geometries sometimes is like the continuation of framing. So I know I'm twirling the model around a lot here. I'm just trying to get a good view to kind of showcase this. This plane here, this roof plane, and the rafters that are coming up to frame this taller roof actually continue across into this white space down here and are resting on what should be down below this basically wall here, which will be a load-bearing wall. So that's why we have this bump out, and let's see if I can try and find a photo of that. It would be a little earlier on here. So I thought I had a photo of it there, but I guess I don't. So we're just going to pull this wall back in. And I know that this is just basically going to be framed vertically above this block out here. And for that, we can use one of these walls, which is just a single gyp facing wall. And I'm going to take that and align it with this space here, since this was my surveyed space. So I'll take that with the inside wall and copy, paste, rotate, align this with, let's see, make sure we're grabbing the right wall here, this wall. And just try and clean this up a little bit. That to there. This to here, this to here. So if you're able to see, this is our space here. We can get some square footages on that now, and I think we can probably even just pop our head in there and get a little bit of an idea of the perspective of the space. So this is 3D view cutting through. We'll take these walls, snap them to the underside of the roof. Attach. This wall. Attach. There we go. So let's drop a view in there. View. Camera view. 3D view. Camera. And I'm just going to grab that, stretch it out. And it's looking pretty basic, so we will, first thing I like to do is extend the width. In the field of view, do about 12 inches, and then scale that to 16. Oops. And after it's scaled to 16, then change the field of view also on the height. And that should give you a 16 by 9 view, which is great for rendering. And it should be about a 90-degree field of view. So if I have that selected and I go back into my plan view, come down here, it's a little less than 90 degrees, which is appropriate for a perspective view. Give you like accurate kind of skewing of the edges. So I always like to make sure that the details are on, get a little shading going on there, brighten it up by going into the graphic display options, lighting, sun, ambient light, bring down the shadows. Okay, and then turn on ambient shadows, get some edges. Okay, so this is what we're working with. Needs a little bit more work, obviously, but I think when you start to get in the space and rotate around, it can help you understand if, okay, maybe the wall heights that we said might feel better at 4 feet are feeling a little too tall. Maybe they strike kind of a strange datum for where your eye level is, and it might feel a little better, a little lower. So these are things, obviously, we'll have to discuss with the client. But making a first pass is really just about getting the geometry right, coming up with a floor plan that makes sense to issue on a set of drawings. So we'll kind of run through the rest of adding a little bit of lighting, dropping some furniture, popping a few skylights in there, and seeing what it looks like when it's just a little bit further developed, and then exporting some drawings for our concept package. So we're actually going to include this bedroom in the scope. I just looked back at my consultation report, and which means I modeled up these existing exterior walls, which are going to stay in place. We have an 8-foot ceiling in the existing bedroom, which is okay. And then this bump out actually protrudes into the roof space here. So let me set this back to show complete. So I'm going to drop a quick roof on there, show you guys how to throw a dormer in so we can get the ceiling plane in and see what our complete space looks like. So if I go back to roof by footprint, and see if I have the option to, yes, put this on ceiling level 2. Sometimes it doesn't hold to that even after you model it in place there, but let's just give it a try. And I'm going to grab those lines, and for dormer roofs, I believe you can just kind of close it off, and then there's another tool to use to snap it shut or snap it against the existing roof there. So I know this one I don't want to have a slope, so I'm going to remove the defined slope character from that parameter. And let's give this a try at, it should also match 13/12. And that looks okay. We're doing the plumb cut on these and snapping it to the base. Let's see if I can get that. And there would likely be a little bit of overhang on that if I double check. Usually it's a lot less, so we'll just take it 12 inches. Don't copy, offset. Bring that one back. And let's see what it comes up with there. So the dormer tool, there's a cutout dormer tool, and then there's actually like a snap dormer tool, and the modify, this little guy up here, join, unjoin roof. So I think if we select this and then this, or you select the button, then the edge of that, and then snap it to that roof, and it kind of pulls it back there like that for you. So that looks great and everything from the exterior, but from the interior, we're not cutting through the roof, so it still shows as the roof plane cutting through that dormer. So to get the dormer cut out, you use the dormer tool, and that is under Architecture, Dormer, all the way to the right here, Openings. Select that, select the roof that you want to cut out of, and then it allows you to grab the pretty much exterior face of these walls. And you might have to go in your plan view to actually grab it. And then the roof, it allows you to kind of grab the roof lines, which gives you those angle cuts, and it's usually pretty accurate. You can kind of toy around with the accuracy of it after it cuts through, but just to get an idea, it's always good to just go all the way through with the tool. And then if I cut my section plane back through that dormer, you can see it's cutting out good enough. At least it's, giving me the opening where I can drop my ceiling plane in, and it's not going to conflict with the roof geometry. So let's do that. Let's drop our ceiling plane in. Now these two existing walls I have kind of ghosted in from the survey drawing are going to be demolished to open up the existing bedroom space into this attic space. So like we said at the beginning, pretty unique sort of configuration of the bedroom area. Very long, narrow space, but wanted to be used as just additional lounge space in the bedroom. So that's been cut out, but I do have the soffit above going up to the underside of the ceiling here. So I can draw in my ceiling, and I'll do sketch ceiling. Take this, and I usually just do my ceilings to the inside face of the drywall. Just chase it around the perimeter there, and this might get a little goofy at the edge there when it does soffits. You have to make sure that the wall, that is a soffited wall, rises just above the 5/8 inch plane for the roof. We'll take a look at that in section, but that should be good. Level 2, 5/8 inch gyp ceiling. Okay. And if I come back to this, no, not level 2, ceiling level 2. There we go. Now we've got our primary door coming into the main bedroom area. And then if I just cut this down, take a look from top view. Primary door coming in, we've got our dormer cut out. I'll throw a window in there. This is the primary bedroom space, which has an 8-foot ceiling, and it's going to remain as such. And then the walls that are going to be demolished and opened up into this interior space here. So you can see our roof geometry is kind of penetrating just a little bit there. We might have to make some adjustments to this wall and plan. But overall, this is, here's what I was mentioning. This wall is set at the ceiling level 2, but it would need to be offset with a base offset of 5/8 of an inch just to clear above that roof line so you're not getting any strange geometry. So this perspective view will serve us as our kind of guiding 3D view. And some of these other views are going to get us just to make sure our sections are cut properly, our walls are in the right space in plan view. So let's take this one and nudge it. So we've hit a point in the design process where we need to start considering code. With a bedroom of this size, we know that we're going to need a certain amount of light and ventilation. And I believe it is 4 and 8% that you need at least 8% light and then 4% ventilation, meaning those windows need to be operable. So we're going to take a square footage here, do some of those calculations, and I know we're going to have to pop some dormers in. And I've reviewed with the client, and we want to start by just taking a look at how those look on the north and south sides. That we think will create a little more of a dramatic look when you come around the corner here and look to see the light kind of beaming in from both sides rather than just at the end. But that's something we can adjust on the way. So I know from the section cut that we had taken, 6.25 was what I needed to use to get to my head height. So I'm going to use that from my perimeter lines here, 6 foot. And 0.25, and I know that's since the roof geometry is the same, I'm going to be using that at all sides. So I'm just going to change this to a dashed line so I know the difference here, mirror it over the edge. And then you can really just use a 45-degree mirror here to get that angle. So this line, we can use a region, filled region, to get that square footage. So I'm going to take these lines and just kind of copy them with my green picker. Follow all around the perimeter there. And then clean up these lines to get our square footage. Okay, and we're at about 500 square feet, 503 or 504 if we're rounding up. So we'll do our calculations and see where that gets us. 504 we'll use. I'm going to go to my window sheet, which should have these calculations on it. And I'd like to make this sort of an automated spreadsheet in the future, but for now, we're going to do it manually. So plug in my square footage. Required. So I know I've got some windows on the, what would be west side. We got to add those up and see what we have existing. But what would be required for the glazing area is 500 square feet, 504 times 8%, so 0.08. We need 40.32 square feet of window. So I'm going to take that and plug it in so it's in our spreadsheet here. We usually just round up to the nearest 41 is required. So I'm going to have to go back and see what the existing windows were on the other side of the room. I don't think it was quite enough, but maybe it'll take off a good chunk of that. And then what's required of the ventilated area will be half of that. So we know it's 20.5, we'll say, square feet. So I just did a little exercise here where I popped in the existing windows that were documented in our survey, a couple of casement windows that will serve as ventilation and light, so they're kind of doubling for us. And then to get the square footages on that, you can do an elevation view. Sometimes that can get tricky if you're trying to map different windows around the entire building. Or what I like to do is just in the view here really quickly is draft that window size and then see what the square footages are on that. So for a 2 foot by 4'4" tall window, we're at 8.67, so we'll say 8.5 square feet for one. And if I just double that by moving this over, it gets us to 17.25, we'll say. So I know that we're going to need a lot more windows, at least if that's 17.25, and we needed 41. Do a quick we'll need at least 2.5, 1.5 more of those, so probably 2 dormers would be good. Okay, so we're going to take a quick look back at our 3D view just to see what those windows look like when they're populated in there. We've got our ceiling plane in, and based on the calculations, it sounds like we'll at least need 2 dormers. I have to remember when you're including the dormer space, that then becomes added square footage. So after you add the dormers, again, that's going to factor into your overall square footage, which is going to up your requirement for ventilation and natural light. So I think we were at 1.5 that we needed. So I think by adding 2, we should be good with the added square footage that the dormers add. So, like I mentioned with the client, we talked about just starting with the dormers at the north and south, which would be the left and right side of these images. So let's model those in real quickly and see what the space starts to look like with those in. Okay, so we got our dormer pretty much modeled in, and it looks like we're at a point where we're probably ready to start modeling in these ceilings. And there's a couple ways to do that, but I like to do it typically as a generic model that I can control void cutouts, but modeling it as a ceiling type generic model allows you to still host light fixtures to it. And then I do that so that I can hide the roof plane above. And if we have a vaulted ceiling structure like this, you can tuck the lights up in between the rafter spaces and still get renderings to appear accurately so that the lights are not conflicting with the rafters, or in this case, the roof geometry, which is a solid. So anyway, that's sort of a detail, but we'll go ahead and model in with a generic model the ceiling plane, which will cover up some of this geometry. We're not going to be able to do a vaulted dormer since we need some structural ties cutting across there, which reminds me we will also need some ties at the upper portion of this attic space, which will look nice. We'll have some beams kind of cutting across the space. So let's model this in real quick. Okay, so like I said, I've got the generic ceiling here, and now we can start to do some void cutouts. So just to show you what that looks like, if I go in and edit my model, create void extrusions, make sure it's set to a decent work plane here, like level 2, sure, okay. We'll do the vertical cuts first, go to our floor plan, and I had set the work plane for the ceiling at this wall plane here. So, and I know that's cutting through it vertically since this jet's in. So we're gonna block out a cut here. And then that should be it vertically. And then I'm gonna want to cut horizontally through the dormer and then the hipped gable there. So let's do this first. Go in 3D, pull it up, and it looks like it's properly cutting. You can see the dark black line there. So that's good. And then let's go again with another void extrusion, set the plane, pick a plane this time, and I'll do this wall here. And I can do this in 3D, or you can set up a section cut slicing through there, but I'm just going to select these walls in 3D here. You might have to turn on the wireframe to get a view through there, and since we're not cutting the top part of that, I can just select the bottom there and basically connect these lines, and I know that that's going to cut through my dormer opening. And then same here, you can see this edge kind of flying out towards the side there. We're going to want to trim that, and we can take it either 5/8 of an inch, pull it back 5/8 of an inch to accommodate for this face that we'll need to do. But and I think I will do that so it makes modeling that next one a little simpler. So 5/8 of an inch, do not copy, pull it back, and just to trim that whole corner basically off. We'll see what that looks like. Make sure your void is pulling through the geometry. And there we go. So I'm not too concerned about the exterior look yet. Well, we're going to get to that at a later stage with the client. So I just really want to get the interior modeling correct. But you can see now, let's take a look at how this looks in 3D from the interior. That's modeled accurately. I know I'm going to get my windows in there, daylight coming in, and it's geometrically correct. So that's good. And then the rafter ties will come in. They need to be at the top 2/3 or top 1/3. So those will be cutting across the top there. We're going to have to put a ridge beam in across the roof to accommodate structurally, but we'll get to that later. But right now, I just want to make sure I'm getting these sort of code required geometric elements in, and I dropped the bed as a piece of furniture in there just to get an understanding of where this dormer should be located. That's going to depend a lot also on the exterior of the home, having a symmetrical or just kind of a well-composed exterior with some of the other dormers that already exist. But also, since you have the opportunity to plan for furniture, it doesn't hurt to just understand how some of these things are going to interact with maybe a king-size bed that's put along this side of the wall. So you can see, that dormer space, if you had a bench or kind of a reading nook, clears the foot of the bed so that it lines up nicely geometrically. So another thing to consider will be where the rafter ties come in. If it's on a regular rhythm, probably wanting to center this dormer on that some rhythm of the rafter ties. But like I said, we'll take a look at that. So let's keep going. Okay, so I just off camera mirrored the dormer over, so you can see that in our 3D view here. I don't know, looks a little peculiar from the exterior view, kind of something we'll need to talk about with the client. But from the interior view, it's pretty neat. So I'll just do a little turn my head here, or orbit the camera. And you can imagine, walking in and seeing this view from here with proper lighting and even some skylights poked in there above maybe. Definitely kind of a, winning rendering there. Something like that. So I'm going to finish up that ceiling plane there, add a floor, and then pop in some lights. And that might be just about it for this concept. And then we'll sort of package it all up to see what we're looking at in terms of a concept design deliverable. So that's our end wall there. I'm going to throw down a quick floor plane in our plan view so we can see what some nice wood flooring would look like in there. So I'm going to go to floor, I've got, like we talked about before, separate our joists with our sheathing, and then I've got a second floor layer that is just the hardwood floor. Make sure that's on level 2, not offset. And then we're just going to run around our perimeter and select the inside face. Usually when I want to be really accurate, I'll go, underneath the actual gyp board like that. And if you can't see it in the view, it's when you get your offset tool out and just pick the outside of the wall and then shift the line in. Again, all these things just sort of help a little bit when you're cutting these things in section. Just makes the model a little more accurate and realistic. Okay, and I think I mentioned also before that this was our square footage, 504 square feet. But like we talked about, once you add those dormers to get the daylight and egress windows in there, it's gonna actually expand our usable square footage, since that is up above 8 feet. So I'm going to adjust this and get an accurate square footage count for us. Since the client is looking to advance this project into construction, so I'm doing the concept design but planning in my head for taking this much further and through permitting and construction. So now with those square footages included, we're up closer to 550, 560, 558. So we'll want to update our little chart here. Okay. And provided, I think we were at, let's see if we have any history there. No, it was at 17 and a half. And I'm basically going to duplicate the dormer that we have, or we did duplicate it, but the windows, I mean. So multiply that by 3. So I know I've got 52 and a half, which is above our required. So we're in the clear for that. 52.5. Copy that over into the provided, since they're all going to be operable windows. So that should be good, and we'll be able to just remove all of this for now. So let's take a look at how our flooring turned out in 3D. It's looking good. We got all our drywall up, so that's good. We got to pop our windows in and then do some can lighting and put the rafter ties in. And that should get us at a pretty good point. I think, we can throw in some low doors here for the storage behind these half-height walls, which will just give us an idea that those will be used for storage. Looks like I didn't quite bring that far enough there, or I think I had a void cutting through it from when I mirrored it on the other side. So let's do those few things, fast forward through this a little bit, and then we'll get to mocking up our concept deliverable set. So I wanted to mention while we're looking at the lighting, lighting in vaulted ceiling systems, you need to always use, or you should, gimbal style, which gives you a little more flexibility in terms of aiming that light or pointing it downward. In many cases, fixed lamps are used as well, but I like to have a little bit of directionality. So I've got a gimbal. It's just a typical recessed light, but you're able to change the angle of the light projection. And so it's always a little difficult orienting it. Just you don't know which way that angle is pointing. So come into your visibility graphic overrides, come to the modeling category and lighting fixtures, and turn on the light source, and you'll be able to see that cone of light. And again, like I just mentioned, it's going to be fixed at I think 90 degrees, but we want to rotate it down so we have a little more downward light than this across light on our gimbal fixture. So I'm going to select that, go into my edit type for this recessed light type, scroll down, and you'll have the tilt angle. And here you can test it out. Since we know it's not a 45 because it's a 13/12 roof, you can sort of play guess and check, but you can also come directly into this view, and it's going to be hidden in the back there, so we don't need to see it necessarily yet. But I want to get the exact dimension that I'm going to need to rotate that to. So just do that by drawing a straight line down or using one of your grid lines, and select the angular dimension tool and check it out. So this is going to tell us it's 43, but it's probably actually like 43 and change. Yeah, here it's 42.71. So if we go back into our 3D view and we set this at, it's either 43 or 42.71, or you have to do 90 minus 42.71. I can't remember right now, but we'll do both ways and just test it out. So if that's 90, pulling it back in a way, I think it's the 90 minus 42.71. So that's going to be 47.29, 47.29. And let's try plugging that in. Okay. And it kicks it, obviously, in this direction. It's pointing away from the camera here. So it looks like I'm going to have to rotate it 90 degrees clockwise. And I go into my reflected ceiling plan, and let's give that a try and see if that's right. 90, go back to my 3D view, and that worked, but maybe it wasn't the 90 minus. Let's try editing that to just be the 42.71. Yeah, okay, that did it. So now we're perfectly perpendicular. And, whether or not your gimbal is really going to get you that degree is questionable. But, want to make this look as good as possible for right now, at least. And so we'll copy this over. We'll come up with a little grid system in terms of spacing along our reflected ceiling plan, and we'll go from there. So what I just did was typically can lighting will be about 6 feet on center. So I found where the soffit cuts up in the existing bedroom here. So that's this line against this wall here. And then drew a line from the hipped gable peak, which is right there. Spaced it out, got me about 1, 2, 3, 4, 5 sections. So that might be something that I use to help align these dormers in combination with the rafters. So I think, for now I'm going to use this as lighting spacing and then probably push those dormers to align with that just for our concept purposes. Okay, so I added the lighting on both sides of the vaulted ceiling. I shifted over the dormers, which gave them a little more space around the bed here, if the bed is going to go there, but also a little more distance from that hipped gable roof there. So what I want to do is just set up a couple test renders so they can kind of cook in the background while I'm finishing up some work here. I know I'm going to want to get this kind of head-on shot here since that was sort of a winning shot. What I'm going to do is just grab my camera and the crop plane in the 3D view and then come in my plan view and just align it to this center line. Make sure everything's lined up nice and neat. So I know I got a straight on rendering there. Come back into my 3D view and then we can make some adjustments if it's too close or too far. That's okay. I think I want to get a little more distance away, capture a little more, and then maybe even open up the camera a little bit. So it looked like it was just under 90 degrees. I think if I add a couple more inches to each side, it would open it up to about 90 degrees. So I'm going to do 18, field of view, apply, click the scale, kick it back to 16, and then click on the field of view again and make sure it's 16 by 9. So that's a little better. It gets us a little more architecture in our view, but I also want to just pull the camera back, so I'll just tab it back a few notches, see what that looks like. We'll go all the way right in front of that wall there. That's too far, so I'm going to want to crop it in probably between this second and third light. So maybe we can use a reflected ceiling plan for that, something like that. Maybe even a little closer. Yeah, I guess how we originally had it wasn't too bad. So that's one shot. I'm just gonna lock it in here, save orientation, lock view. And I haven't named any of these yet, so they're kind of cascading at the top of my project browser there. So I'm gonna rename it Perspective View. Bedroom interior. Elevation, we'll call it. And I think the height and everything is good, like the eye level, but let's just double check where we're at on that. It's hard to gauge sometimes when you're on the second floor. You have to kind of add up where you're at in section. So if my floor plane is at, we'll just say 9 feet, I'm gonna have to add, so if we're at 14, that's 5'2". That's okay. That's kind of a normal eye height. Around 5 feet is pretty good. So if I wanted to get a little more height, I can lower the camera, but this is good. Let's just send this through. So I'm gonna go to my view tab, render, interior, sun, and artificial. And then I always like to just click very cloudy. I think it helps soften the light that's coming in through the windows and things like that. We've got, this is going to be north facing, but this rear dormer on the right side of the screen is going to be east. So I can get some sunlight to kind of gleam in through that window. So I'm going to click on my sun setting there and just do a lighting in session and kind of pick, 90 degrees, maybe even something like 70 degrees azimuth. And then we want to get it nice and low so that we're kind of coming through the window as best possible. So we'll do 15 just to start, see where we're at on that. Level 1 for the ground plane, okay. So you can see immediately it changes the lighting. The sun is going to be coming in from the right side, illuminating the left wall. And this is just a test rendering. We can populate it with some more Entourage and things like that afterwards, but let's give it a go and test it out. So that was our render settings tab. Now rendering cloud. Revit's got great cloud rendering service. Do final render quality, image large, and we'll send that through, start rendering. And then we can check on that a little later. Let's set up our second camera view. So that's locked. I'm going to come over here to the project browser, duplicate the view, duplicate with detailing. Sure, there's no detailing in it, but just in case, unlock it. And then for this one, I liked sort of where we were at, where maybe sitting on the bed or looking from that perspective. So I'll just grab the camera. We'll go back to our plan view. And let's see, we swing this around. This is just gonna sort of be an overview shot. I typically like when my architectural shots are elevation view. It just makes them look a little more elegant, with lines just lined up orthogonally, horizontally, vertically. But this one's going to be a little more dynamic, so we get a sense of the unique geometries that are happening here. So I'm going to walk it back just a little bit, see if we can get even more in our view here. Maybe even like we're sitting on the edge of the bed. Let's see what that looks like. Yeah, that's good. Then we can put like a book and some glasses, pair of glasses on the bed, make it look like we're just reading a book there. Let's see if I want to see that wall to the left. No, not really. I just like it cutting off, but I like seeing the dormer kind of continue off the screen there. It sort of leads the eye. And then we'll just rotate this just a hair, walk it forward. And if you ever render and get like an all black rendering screen, it means that your camera is inside a wall. So let's just make sure that we're not inside a wall. Looks like we're just clearing it there. So that should be okay. And that's not bad. I think that's okay. And we'll set this, since we're sitting, a little lower. Let's try 13, which would be 9 plus 4. So 4 foot above the grade there. And that's pretty good. I think it feels like a good gauge, sense of the space. So I'm just assessing what I'm going to have to do after this. We'll put in some Entourage. We will put in the Rafter ties. And I'm not sure about the doors or not. I think for the conceptual purposes, we'll just leave those off at this point. So this is looking pretty good. I'm going to lock this where it's at, save orientation, lock view. And then again, since we rotated it, the sun would be coming in from the left side or the right. Let's see if it was facing, that'd be a little too far north. So let's just keep it coming in from the left and see how that looks in the rendering. We want to try and keep the lighting in the renderings as accurate as possible. So this one, we're going to swing the azimuth past 180, try and get it coming into this window, not quite 270, but maybe 250. Let's try 240. And the 15 degrees should be okay. Level 1, apply, okay. So again, you see the lighting change in the image, that's fine. And I want to make sure I rename this one. Bedroom. Perspective view. From bed. That's enough. Always save. Let's see. Realizing what I forgot to do here is turn off the roof plane. So that first rendering, we might not get the lighting cutting through there. So I'm going to go back into my axonometric view, grab my roof, and put it on a work set that I have so that I can control it when I'm in those 3D views, and just put it on we'll just put it on exterior for now. I thought I had a hidden ceiling. I have hidden elements, but I use that for other things sometimes. So we'll just put it on exterior for now. And come back in here, and the telltale sign should be, if you see that brown there, that's the underside of the sheathing. Just do a VV, work sets, turn off one of those work sets, hide, and that's gone. So that one should be better. Not sure how this is rendering out here. Let's see if we could take a look. While that's going, I'm going to open this other one, do the same thing. This one, I don't know why I'm not seeing the roof there. Oh, the dormer is cutting through it, but I still want the rest of the lighting showing in the rest of the space, so I'll always need to turn that off in these renderings. Hide. And it shouldn't affect anything from the rendering in terms of not seeing a roof because we're totally inside, so we're okay there. And I'll send this back through. Actually, I wanted to double check my heights. So I noticed that the eye elevation and the target elevation are not exactly the same. They're close, but I want it exact. So I'm going to do 14'3". And it looks like I'm seeing just the edge of that light coming in there. So I'm going to nudge it, this view down just a hair. And I think that's good. We'll lock this and run both of these back through. Render in cloud. Final. Large. Okay. Same thing with this. This angle was good and everything. I think I actually wanted to scooch this up a hair so we're clearing that light and the edge of the dormer ceiling there. So that's a little better centered on the image. Render in cloud. So this one from before seems like it finished. Interesting. I mean, you're seeing definitely some dark spots along that back wall there, but it's sort of cozy. I think with the rafter ties coming in across, it's going to be quite nice. So that one's okay, shaping up okay. Maybe with the lights on, yeah, we're getting a little better illumination from the previous on towards the camera here, so that's looking okay. And let's check this one. Yeah, this is great. So this one, the lights coming in almost too perfectly perpendicular to that dormer. So I want to bring it probably just 90, we'll call it, and see how that illuminates from there. Or actually, I thought this one was supposed to be, oh, it is. It's coming in from the left. But still, for some reason, it just happened to be perfectly aligned with the dormers. Not intentional. But I think pulling it back towards us so we see the face of this dormer that we can see illuminated is a good thing. So I'm going to adjust the sun angle to be closer to the camera angle, so maybe another 20 degrees. Drop it down to 220. Apply. And that looks even better, just illuminating the whole space. We'll get some reflective light kind of coming through there. So those are are okay and good enough for these kind of concept purposes. And now I want to put those rafter ties in, put a little more entourage, and then we can finish setting up our drawings and we'll wrap this up. Okay, so I went ahead and added the rafter ties, and I also populated the model with a bunch of Entourage, so my renderings would look more populated. And edited the views and some of the sun lighting, so we can take a quick look at some of those. In the meantime, in full transparency, it's taken me about an hour and a half to get to this point, populating the images, setting the lighting. So you may notice there's no more harsh sunlight coming in either of the windows. I just have it sort of backlit, so these dormers are just being lit up from the sides here. We've also got this perspective view. Let's see. Rendered up with the rafter ties in there. Same thing, I changed the lighting so that there's no harsh sunlight coming in, but looks pretty nice, populated. I can see it being a pretty comfortable space to have a bed or workspace or kind of combination of both. I think that's what the client is looking to do. So these are the drawings that I have populated. Like I mentioned, I wanted to just put a little concept drawing set together so I can review with the client, where they would want furniture, if that's, of importance and interest to them. So we've got a floor plan. Don't really have the remaining floor populated because this is the primary scope of work here. We had our renderings. I've got a 3D axonometric view that shows basically that area, which is in the scope of work there. We wanted to take a look at how these dormers were going to look on the exterior. That was not in the scope with our contract, but it's obviously going to be important, so we'll have to have a conversation and how much effort we put into looking at this from the exterior. And then I got a couple sections cut through here that are located on the plan. One longitudinal, one transverse, just to sort of get an understanding of what the scale of a human is in here and what your head height space is after you clear these dormers. So this is a pretty good amount of work, I think, for like a first concept delivery package. We do have this 360 view that I had rendered up. Another great feature in Revit, it's a stereolithic panoramic view, which allows you to render everything in 360 and give you this photosphere view to provide to the clients. You can zoom in a little bit, you can zoom out. Really nice. You can put the headset on, VR goggles, and kind of put your client in the space and rotate around. So anyway, I just like to include that and the QR code, so if they are looking at it on the computer, they can pull out their phone and take a scan of that. So that's going to be it for now. Thanks for tuning in and coming along this ride with us. Revit's got a lot of great capabilities in terms of putting concept work like this together, as well as obviously taking it through permitting and construction documents. But definitely as a design tool, knowing when to focus on the right things at what part of the project is really important. And running a business, I have found that pulling some of that more critical construction factor type of work earlier into the concept design process has benefited the overall workflow, just in terms of not needing to redo things or check on codes later in the design. So if you are watching this in terms of design related work or construction document related work, just keep in mind that it's important to marry the two, especially when you're running a practice on your own, if you're a solo entrepreneur. So anyway, hopefully this was helpful to someone out there, and I'll put some renderings up on the screen just to kind of showcase the final package that I put together. Thanks a lot. Bye.